Delivering on the vision of a world computer is no easy task. So let's take a look at how the DFINITY Foundation is navigating that challenge, examining the different steps that we're taking and hearing from those at the forefront working towards making that vision a reality. Before we get started, let's hear from our founder and Chief Scientist Dominic Williams.
Hello everyone, and thank you for joining DFINITY's 2025 Roadmap Update. I'm going to say a few words before handing you over to the R&D folks who will go through the upcoming changes in detail. One very exciting thing I want to draw your attention to is that the Caffeine platform has made it onto our official roadmap for the first time. This reflects the impending dawn of the self-writing internet paradigm on the internet computer and our coming out of stealth and approaching a first release, which will be incredibly important for the internet computer network and ecosystem generally. The self-writing internet is a paradigm that enables anyone to build, update, and own custom internet functionality, such as websites, web apps, internet services, and enterprise applications, just by talking to AI in their native, natural language. For example, an individual might create a personal branding website or a wedding planning portal. An entrepreneur might create an e-commerce website or a sharing economy app with Web3 Rails. And an enterprise might create a corporate portal or CRM system. Anything basically, all just by talking. Apps created using the self-writing internet will be completely sovereign because they run entirely from a public network, and their creators own the underlying source code and the data involved. Plus, they will be tamper-proof, a level of security that delivers immunity to traditional cyber attacks, and unstoppable, a level of resilience only blockchains can provide because they are powered by an evolution of smart contract software. It's a game-changing paradigm. Some new items in the roadmap are directly related to enabling the self-writing internet, such as enhancements to the Motoko programming language, which introduces incredibly innovative, advanced new technology that makes it easier and safer for AI to build solo. But many new advances you'll see in the roadmap are more general, such as improvements in scalability, reductions in data storage costs, and DeFi 2.0 functionalities. We want the internet computer to be the perfect next-generation secure network platform for human developers and AI building solo, and for humans and AI building together. The self-writing internet heralds a new age, and we in the ICP community are on the cusp of something absolutely incredible. With that, I'll hand you over to the folks from R&D who will provide a detailed overview of the roadmap changes. Bye for now.
Now, Dominic just laid out the bigger vision that is guiding the development of ICP. We're here to reflect on the key goals that will drive us for the coming months in pursuit of that vision. To get us started, let's briefly revisit and examine some of the key components that factor into the vision that was just laid out. I am joined by Jan Camenisch, Chief Technology Officer, and Samuel Burri, Vice President of Engineering. Welcome, both.
Hi, Tracy. Pleasure to be here.
Now, Jan, clearly there's this bigger picture of a world computer that we're working towards, but for the uninitiated, how has this inspired and influenced the design of ICP?
Our mission is to reinvent compute because the current IT stack no longer really works. For instance, last year, the cost of cyber attacks was more than $10 trillion. Maintaining, operating software has become much, much more costly, and these numbers just increase like crazy. So we need to take a different approach and reinvent compute, and that's what the Internet Computer Protocol does.
Now, one of the key components of that approach revolves around sovereignty. Can you shed a bit more light on that?
Yeah, because the complexity of the current systems, it was no longer possible for people to maintain their systems themselves, so they had to use cloud computing and give away their data, their software into the hands of third parties that run these softwares for them.
Yeah, first you want to make sure your compute and data is not just placed on one single machine. You replicate it across many machines. And additionally, you then want to make sure that these different machines or nodes are not controlled by just one party. They should all be controlled by different parties, by different entities. And so as a result, you no longer have a single point of trust. You have no single point of failure. Security increases, reliability, robustness increases. And that leads then to these higher security guarantees.
Okay, so you have this sovereign, secure platform. But I guess then the natural follow-up question is a platform on its own enough, or are there additional elements and components that need to be built on top?
Well, a platform is like an island, right? Out in the ocean, nobody can reach it. So you need to make it easy for people to use this platform because it's a new platform. So it's all about adoption, ease of use, both for developers and users. So you need additional services on top of that, such as like payment, which in this space, of course, payment tokens is sort of built in from scratch, but you need other stuff like identity, so people can, prove stuff about themselves, can authenticate in a secure way, can easily use their these applications that developers build.
So there's sort of a core suite of services or features that need to be built out in order to help bridge the gap and make it a bit more user-friendly for developers. Now, Sam, what Jan just described is obviously quite an undertaking with a lot of different components that need to sort of symbiotically contribute to the overall success and adoption of the technology itself. What does the ecosystem look like today, and how has adoption evolved over the course of the last year or so?
We have seen phenomenal growth in the last few months, which makes me, I think, our entire team super happy. We have seen the cycle burn, so basically usage going up. If we look at the last Electric Capital report, in terms of dev growth, we're only second to Solana. So ICP is really at the forefront. And that's very motivating for the entire ecosystem. At the same time, you see super attractive new projects. We have been working a lot on the chain fusion. Chain fusion allows you to hold and control assets on other chains. And that's also a perfect means of not just forcing developers or end users to jump ship and go directly from some other chain into the ICP world, but they can keep their assets where they are, they can keep the smart contracts where they are, but augment them, and that allows to make a transition step by step, or just use both.
Now, obviously, Jan, this is an incredibly powerful technology, but that also comes with a bit of a different set of hurdles with regards to other Web3 protocols when it comes to actually onboarding new developer talent in particular.
In the last year, we've really started shifting more towards analyzing funnels where users come in, where developers come in, where they drop off, and we're removing a lot of these friction points now. And one of the milestones of the roadmap also is ICP.Ninja, or the milestone is called Colomb. And there's about first-time developers that just want to experiment with the platform, see what ICP is all about, what you can do on it. They can go there just using their browser. They'll see some samples. They can compile those samples in the browser, upload it automatically onto the ICP network. They try it out and also see how it is for developers to write smart contracts on ICP. Every smart contract on ICP has their own URL. And that's all they need to do. Just enter URL and you're done. So check it out. Go to ICP.Ninja and try for yourself.
AI is a wonderful tool in this regard because it allows users or developers to get off the ground very quickly. So you write the prompt and boom, you have a small application. And you write some more prompts, you modify it. And so the time you spend from let's give it a try to something is working is shortened significantly, and it gives you the feeling, wow, it works, and it makes you more curious. And of course, then you want to dig deeper. You may then have to learn some of the new terminology, new concepts.
So Jan, about a year ago, we published the first roadmap in this particular format, and today we get to present an update. But before we get into the specific components, what is the purpose of the roadmap?
Of course, we always had a roadmap at DFINITY to plan our work in R&D. But a year ago, we said, okay, let's communicate differently about what the work we do. And so let's make a public roadmap where we have different areas where we're working on, and then within these areas define some milestones so that people can actually see what's coming, developers can plan, everybody can get excited about all the cool stuff we're doing there.
Now, I'll quickly recap the themes at a very high level. We had compute platform, decentralized AI, chain fusion, privacy, platform decentralization, identity, digital assets, governance and tokenomics, and developer experience. So those guided, I guess, at a very high level the direction that we went. But of course, you just mentioned there were individual milestones that featured within those themes. So perhaps for those who are a bit less familiar to what the previous 12 months have looked like, I'd love to just maybe quickly touch on some example milestones from last year. So I don't know if, Sam, maybe you can share what your particular favorite was from the previous year.
One milestone we launched towards the end of last year, and it was all about latency. And latency is how much time it takes from you load or click in your browser to you get the application back or you execute the transaction. And with this milestone, we managed to, in some cases, halve the latency. So now it's twice as fast. And such a milestone is an enormous engineering achievement. So in this particular case, it was about 10-person year of work that were necessary to making this happen. And then having the milestone and presenting it and telling a story around it allows you to have more impact, to explain it better to a broader audience, why you do it, what's the achievement. So I think that shows how this format proved to be really impactful.
Yeah, this was a cool milestone. It also allowed Bob.fun to really bloom, right? My favorite milestone is it's actually more than one milestone, but around chain fusion, which on the one hand also it allowed for Odin.fun, right, which is runes on Bitcoin that are transacted or sold on ICP. So you can see how like developers actually picked up doing ICP smart contracts that work together with other chains, and it really shows that we're getting tractions, we're doing the things that the community needs and wants.
So now that we've established the purpose of the roadmap, let's look at some of the key areas or themes in a bit more detail. We'll start with what I'm sure everyone is keen to hear about, decentralized AI.
Sure. We spoke before about AI being able to help you onboard more quickly. So with a few prompts, you create your application, your dApp. So that's built with AI. But there is another angle, and that is sovereign AI. So yes, indeed, we are all super impressed by these LLMs, and it's amazing what they can do, and we want to use them. But at the same time, it's highly intransparent where our data that we feed into these models go, and we also don't know exactly what data was used to train them. And so that's a wonderful play for, again, sovereignty, and it goes back to the vision that Jan explained. How can we now still use these models, but retain as an end user our sovereignty so that we are in control and know where the data goes? And this is what we call sovereign AI, and we have a number of projects and a number of activities around this that you will find on the roadmap.
And sovereignty is really just one aspect of this, right? So there's also the sort of dual aspect, which is the security of AI, because AI is not really code that you can read, but just a bunch of matrices. And so in order to have trustworthy AI, you actually want to do the training with the data on chain, right? And so if you have it as a smart contract, really know, okay, they all went in a secure platform, so you can trust it. And that's another very important aspect as well.
So then, Sam, you just mentioned there's a number of different components in the new and updated roadmap that touch on this. Can you give us maybe a bird's eye overview of what it is that you're looking to further build out?
So one area is just improving the core protocol. If you run AI models, they need a lot of computational resources, and we're constantly making sure that you can run bigger multiplications of matrices, that you have more memory at your disposal. So there's a whole area of improvements of the core protocol that we work on. Then we now look into how can some of these really heavy compute workloads be offloaded, but still be governed, controlled by the blockchain or by ICP. And here we talk about AI workers. And the third area of interest is agents. So again, if some software does some work on your behalf, such as an agent, again, you want to have the security, you want to have the sovereignty, that you have assurances what this agent does. And that's something we look into. And we will see these agents pop up in places like wallets, for example, OISI.
Now, we'll get into OISI and the digital asset landscape in just a second, but Jan, I'd like to invite you to expand a bit on something that we touched on briefly, and that is building with AI. Obviously, a significant portion of the roadmap also touches on improvements and exciting new innovations in that particular area. So maybe you can give us a couple of insights.
I mean, it's really great how AI has developed over the past couple of months or the last year, really. As it turns out, actually, ICP is the perfect platform for coding with AI, because on traditional IT systems, you have like a ton of components, a database server here, like a backend, something here, and you have the accounts and logins everywhere. And so that's actually a very complex system that now AI has to master. Whereas on ICP, you just simply build a single smart contract, or maybe two if you want, right? But it's all enough. Like a single smart contract can serve web and can retain data. You don't have to have all this complexity. That actually makes ICP the perfect platform to build with AI.
If you now update your application with a model, you may do that very frequently. And so at the same time, you want to retain your data. That is wonderfully supported by what is called orthogonal per system, which is another unique selling proposition, basically, of ICP.
Yeah, we really want to tap into that, right? So that now AI allows many more people to code, right? And so we want to use this, and that's our milestone around Caffeine, like a tool for not only for developers, but like for everybody, for Web3, Web2, our parents, our children, to code with AI and actually to easier launch their smart contracts. You just talk to your phone, tell it, I want to have this website that manages my next meeting, or we want to do some bet, or we want to, whatever you want to do, just say it, and like minutes later, you have a URL there you can go with your browser, and boom, you're done.
So I guess that factors into that self-writing internet paradigm that Dom often references. I'd like to zoom in a bit on the developer experience when it comes to building on ICP, and it sounds like Caffeine will be well positioned to significantly help lower those barriers to entry. But that said, what additional tools and steps on the roadmap will help serve a better developer experience?
We're focused now on removing these points of friction, and so we've started a number of activities, and there's milestones here as well. One of them is ICP.Ninja, but I mean, that's just like one entry point. There's of course also more professional developers. I mean, they wouldn't use a browser-based tool. They have a larger system. And also here we have a lot of work that's going on, right?
We have today the tool that's called DFX, that is sort of the command line interface tool. And what maybe is important to first mention is, if you build for ICP, you're not just building a back-end small smart contract. You can actually build a full stack application. And the full stack application contains a front end, so you do front end development, you have a back end that can store gigabytes of data. And so a developer experience needs to cater for all of this. And DFX is designed to do that, but because it does so much, it does build your application, it deploys it, it manages the smart contracts, it manages your identity, it manages the resources, so the cycle. And there is somewhat strange dependencies, or just over time, this became quite a fancy Swiss Army knife. And so now we are thinking about how we can maybe pull this apart and create smaller tools that then are less dependent on each other and more self-explanatory. And this is something we look at the moment, and we think, how can we create the next generation of command line tooling that is, as you mentioned, then for the advanced developer that really wants to be in control of every aspect.
Of course, an additional, let's say, resource that is key for developers is documentation. What, I guess, upgrades or changes can developers expect on that front?
So here we look at overhauling the structure of the documentation. So we want to actually make it smaller, but more concise, really work out the essence of it. And another area where we've seen in Motoko, with this AI focus on Motoko, we have also seen how it's sometimes hard to get started there. So we are actually kind of reworking the whole Motoko documentation.
I'd like to move into the third theme, which is governance, specifically taking a look at control and ownership frameworks, which is pretty unique on ICP. What are some of the additions to the roadmap that touch on governance?
The Internet Computer Protocol has its own governance, which is the biggest DAO, like a decentralized autonomous organization that governs the Internet Computer Protocol. And here we have the NNS, the network nervous system that governs that, where people can vote. We have a number of milestones in that area, make it easier for people to vote on the protocol, but also on applications like that SNS, we call them service nervous systems, so that, like, for instance, OpenChat is like a total autonomous organization end to end. So the OpenChat users can stake OpenChat tokens and then govern that. But that's just like the one, maybe the extreme end, where you have like a whole organization. But then it boils down to like maybe smaller organization, maybe non-decentralized organization, to individual users. And so here we also have a nice tool. Sam, you want to tell us about Orbit?
Sure. Orbit is both, it's a specific wallet, I guess we will talk about this in a bit, but it's a framework that allows you to define quite complex rules on how multiple parties, multiple users together can control assets, change digital assets. And that is a fundamental building block to create sophisticated control systems that allow organizations to control their assets with higher security.
This is also really a game changer for organizations. If you think back about our vision of like sovereigns and sovereignty and control, like in traditional IT system, you have system administrators, right, that can control different applications. On like a protocol such as ICP, actually, you no longer have that. It's all a protocol. It's all governed by the protocol. And then you can use actually tools like Orbit, where an organization can now define, okay, in order to upgrade this software, to change this functionality, these are the set of people, this is the workflow, how you can govern that and make sure actually your application is secure. It's no longer some system admin that can run away with all your money, stuff like that, right?
So maybe you can actually say it's an admin-less system, right? No admin with all these superpowers. And that's not just Orbit that makes it possible, it's the entire stack that needs to be as it is on ICP to make this possible. And if you think about it, no admins, that's quite powerful.
Now, you had briefly mentioned SNSs as, again, sort of a core way for the community to organize around applications, etc. There's a couple of specific improvements targeting SNSs. Maybe you can expand upon those.
SNS is a framework that was first used big time about 2 years ago. That was the OpenChat launch. And since then, there's been more than 2,000 such SNSs that were created, new communities were created. And they all dominate now these charts of DAOs across the entire Web3 world, which is super exciting. At the same time, some of these SNS struggle a bit to really make use of their tokens. And so here we think, for example, to propose changes so that when you create an initial SNS, that you would already allocate some of these tokens to go into liquidity pools so that the token that is created is actually tradable. And additionally, we think, how could the whole swap experience be more engaging, how you could retain those users to come back and be active community members. Because otherwise, it's a one-time thing. You create it once, the token is not really heavily used, and that doesn't really live up fully to the vision of SNSs. As always, these are ideas. We discuss them or we present them to the community, and ultimately it's DAO and NNS vote that decides whether this is then released in the be the latest update of the framework.
Historically, many of the most popular use cases in Web3 have revolved around the digital asset ecosystem, linked more closely to financial asset. What updates can we anticipate on that front, starting perhaps with OISI?
If we talk about digital assets, we should not just think of fungible tokens and NFTs, right? Think of our digital life. I mean, we all live to some extent in the digital realm, and we have our assets there, be it our identity, being compute, being documents, and all of these should remain sovereign. And if we now talk about wallets, they are the main gateway or entry point into this digital life. So in a way, what a wallet is in Web3 was a browser in Web2. And therefore, wallets are essential. And let's, again, not just think of NFTs or fungible tokens. One concrete example where we worked on was OISI, which is more a classical wallet, but nonetheless super important as such a gateway. It started out more as a Chain Fusion showcase, and then in the last few months we've really dedicated a lot of resources to make it a very attractive, slick wallet.
It's not just a classical wallet, right? It's like that's for the functionality, maybe that's true, but I think it's like fundamentally different. I really want to stress that, because OISI is like a browser-only wallet. The main difference is, like with normal wallets, you always have like a seed phrase. You somehow need to take care of your keys, and that's like, I mean, it's the craziness of crypto, if you want, right? People have to have cold wallets, hot wallets, and all of that. But if you think about it, it sucks, right? People lose their stuff on some dumpsters, try to find it years later. But OISI solves that, right? And so that's like shows, I think, a good example of how we care at DFINITY around user experience, right? Because it always separates the aspect of authenticating, of user managing their keys with like how we actually manage the cryptographic keys.
And then maybe another digital asset milestone that is worth mentioning, the Poloidal milestone, is a milestone that is also just around the corner. Here we talk about the Orbit wallet. So we spoke about the Orbit framework as a way to manage assets as a larger organization. On top of that, we built the Orbit wallet, and this wallet was now used for multiple months by the foundation to manage our treasury, or at least part of our treasury. And you can imagine, as foundation, you want to make sure that your funds are not just going anywhere. So you have processes, Four Eyes principle, etc. These are all functionalities that you would find in this Orbit wallet. And with this upcoming milestone, it will become accessible to a wider audience. And I'm very excited to see that hopefully more people will use it, because I'm very convinced it addresses key use cases, key needs of bigger organizations managing their digital assets.
Now, something Jan just touched on is a nice transition into one of our final themes that we'll touch on today, which is identity. There's some important updates relating to identity on the roadmap that address the need to balance that user-friendly accessibility and self-sovereignty. So I'd be curious to know, how does identity function on ICP today, and what improvements are on the horizon?
It has many aspects, right? Like one aspect is like, how do you authenticate yourself? How do like prove that you have the access to some systems, the authentication login part. Then there's like more other parts where actually then you have to exchange information. You know, when you log in to a traditional IT server such as Amazon, yeah, you have your email address and password, which is like a very bad form of login, obviously. But then once you're logged in, you have like your favorite books there, you have your credit card, there's all this information. And credit card is some information like from that links your account to your bank account. And so identity is also about like all the attributes that you the other, like the service has to know about you, or that you share with your service. So it's these two aspects, right?
So there's like a privacy preserving element to it as well.
It's actually very important if you talk about data sovereignty. If you're not under control of your identity or your identities, right? Like you know the different stuff about me than Sam does, and vice versa. So in natural life, we're sort of used to manage that. Online, we've lost that. It's all login by Google, and then in the back end, all these services share all their information. So you're sort of fully transparent citizen, right? And I guess blockchain or the intercomputer protocol actually holds the promise to solve that.
Now, internet identity specifically utilizes a thing called pass keys, and there's some improvements, I guess, relating to that particular element.
It's like an authentication protocol where you on your device, you unlock your cryptographic keys with your typically biometric, fingerprint, face recognition. So you give like a security chip permission to actually do a protocol with like a service, right? So but now it's a cryptographic secure authentication to that service. And actually, passkeys also have privacy built in, that they generate a new public key for every service that you're using. And so now there's a number of challenges with that, because now you're using different devices, and then you have to maybe onboard all these different devices to all the different services, which is like huge complexity. So when we built internet identities, we set out to actually solve that, so that you could bundle your devices once at the internet identity service, and then log in with a different login with each service you do. But once you've bundled all your devices, you could use any of your devices with any of your like identities or logins, really.
Now, obviously, what you just described is a fairly complex technical process that happens in the background, but I'd be curious from the user's perspective what that experience actually looks like. So if I, as a user, try to access a dApp built on ICP, how do I log into that service?
Let's say you go to your chat application, you navigate to the website of that, and now you use your fingerprint to unlock the device keys that you have locally on your device, and then your device authenticates to, in this case, the chat application on ICP.
Okay, so a fairly simple, straightforward process, you could say.
It's really this simple, right? Just 2 steps. Actually, so there was one more step. You might have to confirm or select your internet identity, which is because of the fact the passkey protocol, the WebAuthn protocol, worked in the past. Now there have been some updates actually that allow us to even get rid of that, so we can make it even simpler, even more smooth. And I'm looking very much forward to the new version of internet identity that is coming out soon.
All right, so let's move into the final theme that we'll discuss. We've previously referenced the term chain fusion. Sam?
Chain fusion describes a set of tools or functionalities that ICP provides. One part of that is signing capability, threshold signing. So there's different signing protocols, and ICP by now supports the most commonly used ones among the crypto world. So you can sign transactions and then send them to other chains. And additionally, you can read from other chains. So you can see what happens on other chains because you can read them, and you can send a transaction. So basically add to these other blockchains. And the signing happens in a decentralized fashion by running these threshold signing protocols. That's a quite unique capability of ICP and makes it then possible to hold, control assets on ICP without relying on bridges that are a single point of trust. You can now think of a world where you have one place where you can hold and control all your digital assets, irrespective on which chain they are. And that addresses a lot of pain points that are today present. So for example, if you want to have or transfer assets from one chain to another, you may need gas on one chain and on the other chain. You may need different wallets on one chain and the other chain. You rely on liquidity pools that are fragmented among different dexes because every dex only covers a part of sort of the crypto universe. And with chain fusion, you can integrate, glue these all together and overcome these limitations, and additionally no longer rely on these single points of trust as many other protocols too. That's sort of the vision that we aim for.
Yeah, I was really happy to see like this technology, chain fusion, being picked up by project. Also seeing that people realize that with ICP, when you write smart contracts with ICP, you don't need bridges. It's all built in. There's no additional security assumption. So it's all at your fingertips, really. And like last year, we've worked in Bitcoin integration, EVM chains. And now this year, we're focusing on also getting Solana, because Solana is a protocol that works quite differently from Bitcoin and EVM chains. So we're building like a gateway to Solana, such that the smart contracts can just easily interact with the Solana smart contracts.
That's the Helium milestone.
And with that, we come to the end of at least this discussion, by no means the end of what looks to be a very exciting road and roadmap ahead of us. We're looking forward to staying up to date with what the R&D team is doing. Now, if someone wanted to go and check out the roadmap, look at the different updates, etc., where would they go about doing that, Jan?
Please have a look at internetcomputer.org/roadmap. Check out the various milestones. Reach out to us and give us feedback. Let us know what you think.
All right. Thank you both so much for taking the time and joining us today. It's been a really exciting chat. And to those of you joining us digitally, thank you for tuning in. As always, if you're looking to stay up to date with the DFINITY Foundation, the ICP community, feel free to follow us across X, LinkedIn, etc. Do make sure to give our YouTube channel a follow if you enjoy talks such as these. We do a lot of these types of deep dive sessions on the channel. And mark your calendars for June 3rd. We'll be hosting the World Computer Summit here in Zurich. And you are, of course, all invited to come and partake. Thank you so much, and until next time.